Hello, everyone. Thank you for joining us for today's California Mobility Center webinar, a holistic approach to designing next-generation commercial vehicles. Everyone is in listen-only mode. However, you are encouraged to ask questions by using the Q&A box in Zoom. Today's webinar is being recorded and will be available to all CMC members following the presentation. At this time, I would like to turn this webinar over to CMC's Chief Operating Officer, Mark Rawson.
Good morning, everybody. Welcome to our monthly webinar. I'm super excited about today's discussion. Greg Weber from EAVX is going to give us a discussion around electrification in the commercial vehicle space. EAVX is a new member of the CMC and brings significant industry expertise to the space of what it's going to mean to electrify commercial vehicles for fleets in the medium and higher areas. As most of you know, a lot of electrifications happen in the light duty space. But as we go forward, and certainly as the state of California and other parts of the country and globe seek to electrify larger penetrations of our transportation fleet, commercial vehicles play a very important role in accomplishing that policy. So today I'm really excited to have Greg walk through EAVX's perspective about some of the challenges of electrifying the commercial vehicle space and what they're doing to address some of the transition strategies, anxieties, etc., that commercial fleets are going to face as they move forward in electrifying more of their commercial vehicles. So welcome, Greg. Looking forward to the talk, and we'll take questions at the end. So please use the Q&A function at the bottom. We'll have Greg make his presentation. I'll monitor the Q&A, and then we'll save time at the end for you guys to pick Greg's brain and hear his thoughts. So Greg, welcome, and I'll turn it over to you.
Okay, thank you, everyone. Looking forward to our discussion today, hoping to get good questions at the end of it. So the topic today is a holistic approach to design next generation commercial vehicles. I work for the EAVX division of JB Poindexter. And my screen is now frozen. Uh-oh, there we go. I'm the Vice President of Engineering. I've got a broad background in automotive development, including ADAS, mechanical design, electronics control software. Worked on projects all over the world, and recently joined EAVX, a JB Poindexter group, about 17 months ago to head the engineering and technology development. So JB Poindexter is a large mobility company focused on commercial vehicles. Our brands include Morgan Olson, which produces walk-in vans, Morgan, which produces box trucks, Redding, that makes utility work trucks, Tag or Lear, which produces tonneau covers and caps, Master Rack, which upfits commercial vans, and Specialty Vehicle Group, which designs funeral coaches and limousines. The EAVX division is the innovation hub of JB Poindexter. We work with technology partners and chassis partners to integrate their technologies into next generation vehicles. And a little bit of introduction to us. So we're helping to meet the growing demand for zero emission vehicles by integrating our body technologies with the chassis partners and technology providers. We provide technology enhancements to improve the driver efficiency and aid in reducing the driver shortage by broadening the demographics of people who can drive the vehicles. The workspace, truck space is really diverse, but so are the needs and drivers for the next generation of trucks are diverse as well. So the four pillars we consider are society, sustainability, business, and regulatory when considering the drivers for the next generation vehicles. So from societal drivers, we have greenhouse gas reduction, air quality improvements in underserved areas, and reduction in energy independence, or an improvement in energy independence for the US by going to EV vehicles. We're looking at sustainability, so real recyclability for our vehicles, reduction in rare earth elements by going to smaller batteries, and reducing the overall CO2 footprint for the production of the vehicles as we go forward to improve the overall CO2 and greenhouse gas life cycle of the vehicles. From a business driver perspective, we're helping them tackle driver needs. We're improving the visibility of our vehicles to broaden the driver demographic. We're providing systems that will reduce the time to train new drivers and improve the driver efficiency experience, and develop technologies towards safety and convenience for the drivers. We're also integrating technologies that'll help protect the vehicle and reduce damage and accidents, so to keep the vehicle on route and improve the serviceability of the vehicle going forward, and also reduce the total cost of ownership by providing greater equipment safety and security, reducing the capital expense, and integrating EVs into or more electronics into our vehicles to improve the efficiency. From regulatory drivers, we've got emission regulations like the ACT or Advanced Clean Transportation requirements. There's new idle mitigation requirements that are coming in from California and some of the other states. Small engine elimination, and the new thermal refrigeration unit regulations that are starting to drive a shift in technologies towards our vehicles also. So if we looked at all these requirements and drivers individually, we would come up with individual solutions for these. So we're stepping back and we're really looking at the broad questions and needs of our vehicles and trying to address solutions that address all these concerns for our vehicles and allow us to move forward with a much more efficient and cost-effective product than if we design things individually. So for EAVX, one of the big keystones of us moving forward is a digital architecture and connectivity for our vehicles. So providing a solution for our drivers that gives them the information, automation that they need to improve their efficiency and reduce driver distraction. So giving the driver the information he needs when he needs it and only when he needs it, and giving him the automation when he needs it also. So to talk a little about the technologies we're looking at is going to a single integrated display going forward rather than having an individual display for each of the systems that we're integrating, and provide the information on this display when the driver needs it. So let's say the driver's in an urban route, he turns on his right turn signal. This display would automatically provide the right view camera and the rear view camera, and any vulnerable road user warnings from the radar systems looking for bikes or pedestrians that might be in the blind spot of the vehicle. So providing the information to the driver when he needs it. And so also, if you're coming up through a blind alley and you can't see around the corner, turning on the forward-facing camera with a 180-degree view so that you can see down either side of the roadway, so the driver can make a safe exit from the alleyway, even though he can't see from the sight lines. And then backing the vehicle up, having the surround view cameras come on automatically when you back up the vehicle so that the driver gets the displays he needs when he needs it. Also having ADAS systems that warn the driver if he's potentially going to have a forward collision or go out of the lane without using his turn signals. We're also developing tools to help the driver better utilize his tools in his vehicle. So a system that would, if a driver goes to leave a site and he has a high value tool that is not in the vehicle when he's leaving the site, warning him before he leaves that he's missing that tool, so he can go back and get that tool without, so he doesn't lose high value tools when he goes from site to site during the day, or goes home at the end of the day. And that'll all come up through the integrated display. And then for on-site, you could either control locking or unlocking the side cabinets for a vehicle or the lighting for a vehicle through the central display, or using driver proximity sensors that know where the driver's at and turning on work lights where the driver needs them, or unlocking cabinets when the driver walks up to them. And in addition to that, also locking or warning the driver if he's leaving a job site and he has a cabinet that's unlocked or open, so he doesn't leave a job site and lose tools or other things out of the side of the truck because he forgot to close or lock a cabinet on his way off a job site. And all of those you can either automate through the proximity notification of where the driver is at, or through the central display in the vehicle that we're developing. And then simple things like door automation. So a lot of repetitive stress injuries come from drivers opening and closing doors, and it also takes time. So knowing the driver actions and keying on things ahead of time so that you can start to open the bulkhead door so a driver can get to the back of the vehicle when he needs to, without waiting for the door to open or without manually having to open the door and risk repetitive stress injuries in those type of things. So automating systems that the driver needs when he needs it so that he can do his job more efficiently with reduced stress on his joints and bones. One of my favorites is for EV vehicles is the thermal systems for the vehicles. So today, some of our customers have specifications for heating systems for the driver and the cabin of 45,000 BTUs. So if you just do a little simple math, 45,000 BTUs is about 15 kilowatts. And if you look at 15 kilowatts over a 10-hour shift, that would mean you need 150 kilowatt hours of battery to run the heating system alone for the vehicle during the day. So obviously that's not a very efficient way of utilizing the battery in an EV vehicle, and not to mention the cost of it. So if you even use a simple number like $300 a kilowatt hour, you could be talking a $45,000 battery just to run the heating system for a driver while he's running a route in a cold environment. So developing thermal systems that are very focused and targeted heating and cooling to keep the driver comfortable and keep the windshield and side windows clean so the driver can drive safely is extremely important use going forward. Otherwise, EV vehicles just will not be able to be used in cold climates without these systems, because you consume the entire battery just on keeping the driver warm. Integration of telematics and connectivity is absolutely critical to these systems going forward. Improving driver awareness, improved routing information so we can be efficient, and service information uploaded to keep the vehicle online and keep the repairs so you can have repairs ready and waiting when the driver comes off route at the end of the day is very important to keep these high value assets active every day in their routes. And another thing that is critically important for EV vehicles heading forward is aerodynamics. While a walk-in van, most people will look at it and say, well, it doesn't go very fast, so aerodynamics aren't important. But in the development we've been doing, we've seen about a 40% reduction in aerodynamic drag for our next generation body design. On the right-hand side, you'll see a rendering of what one of the designs looks like. And that 40% reduction in aero drag provides about an 18 kilowatt hour reduction in energy over a driving cycle, mimicking a last mile delivery cycle. So it's basically a drive out to get on route, stop and go traffic while en route, and then a highway speed drive to get back to the depot at the end of the day. So that provides about an 18 kilowatt hour improvement. If you look at that in this and just do simple math, assuming about a mile per kilowatt hour, that gives you additional 18 miles of range for the vehicle during the day. Or you could reduce about $5,400 worth of battery with that improved aero, because you don't have to expend that energy on aerodynamic drag. So again, assuming about a $300 per kilowatt hour for battery and 18 kilowatt hours, it's about $5,400 cost reduction in batteries you could do just by improving the aerodynamics of the vehicle on a defined route with a defined drive cycle. Next is driver ergonomics. So climbing in and out of the vehicles is a huge strain on the drivers. So getting floor heights down with work with our next generation chassis providers is absolutely critical. But other improvements include improved sight lines. So we have to improve the demographics of drivers heading forward, or broaden the demographics of drivers heading forward. If we're going to meet the driver needs, ability to get driver needs headed forward. So designing vehicles for sight lines that suit both a 95th percentile driver and a 5th percentile driver are absolutely critical heading forward to broaden the demographics of drivers for the future. Providing feedback to the driver, providing the correct information and displays to the driver to reduce training time and improve the efficiency of the driver is also extremely critical. And then materials optimization is a big need moving forward also. So design to meet the requirements of the vehicle, basic recyclability, and the temperature profiles of the vehicle. So today, a lot of the vehicles are aluminum skin vehicles. They get very hot in the summertime, very difficult to cool with an aluminum skin. So looking at composite materials heading forward that will insulate the vehicle a little bit better and provide a better work environment for the driver when they're in it, is absolutely critical. So we've done a complex Pew matrix looking at different needs for the vehicle, external skin of the vehicle and materials of the vehicle versus cost, and looking at a significant improvement in both weight and efficiency of the vehicle moving forward and recyclability of the vehicle moving forward with new materials that we're looking at. The next thing to talk about is exportable power. So today's vehicles generally power hydraulic equipment compressors with internal combustion engines. Some of them carry their own internal combustion engines. Others run off the power takeoff of the vehicle today. So next generation vehicles are going to have to be able to provide exportable power for different needs. So we're looking at systems that go from 3 kilowatt hours to 60 kilowatt hours in a modular fashion of batteries. So that depending on the use case of the vehicle and the equipment being used, that we can provide the right solution for the vehicle and the use case. So compressors that run pneumatic tools, paint sprayers, that we're electrifying those with battery power that will provide for it. Hydraulics to run cranes and bucket trucks. Exportable power to charge lawn and garden equipment or power tools. Emergency exportable power, or just to run a construction site with 110 or 220 from the vehicle. And then last but not least, with the new thermal refrigeration unit regulations, electronic reefers that have either internal or either powered off of the vehicle, EV vehicle battery packs, or off of a battery pack that we can provide for the customer They can run the thermal refrigeration unit so they don't have to idle the vehicle or run an engine to keep the refrigerated unit in the back cooled when you're parked. And last but not least, optimize integration to the chassis. So we've got a lot of over redundancy today in design of the vehicle body and the vehicle chassis. So today we're working for the next generation vehicles with a large breadth of chassis providers going back and forth on design and requirements and designing a holistic approach to the vehicle, integrating the body and the chassis together so that we're not overdoing the strength of the vehicle, reducing the amount of materials needed in the vehicle going forward, and providing a better solution for the driver from a thermal standpoint. So overall approach enables a more efficient product, both from a cost and weight perspective than if you design the systems individually. And here's a rendering of a couple of our future design vehicles. If you notice, it's got a very aerodynamic front end, meant to significantly reduce the drag of the vehicles going forward. It has a very low step-in height, reducing repetitive stress injuries, and the external materials help reduce the thermal load on the vehicle and the driver going down the road. So with that, I wrapped up a little quicker than I thought, but we can open it up to questions.
Great. Thank you, Greg. I sent a little note out on the chat to everybody. If you have questions for Greg on his presentation and you know, where EAVX sees the commercial electric vehicle space going, please submit your questions in the Q&A section. As the host, I thought I'd take the prerogative of asking a couple questions.
Go ahead, Mark.
Got to know Greg and his colleagues there at EAVX, and you know, what's really struck me, especially when we start to talk about the commercial vehicle space, it is just a completely different market than, you know, the light duty vehicle space.
Yep.
And what's been really interesting and eye-opening for me is you know, we've come to know EAVX and the family of companies that you represent, is this this intersection between the chassis and the you know, and the body of the vehicle. You know, a lot of people in the electrification space focus on the electric chassis and the electric drivetrain, but there's a lot of other things when we talk about connected, autonomous, shared, and electric mobility. There's a lot of other technology innovation happening beyond just the drivetrain and the electric chassis. And what struck me is, you know, how you guys are approaching some of the challenges when we think about electrification. So you talked about weight reduction, you talked about efficiency, operation of the vehicle itself, improving efficiency for the drivers themselves. Could you maybe give me kind of your view on the trajectory of, from an industry perspective, of how you know, these new sensors, displays and whatnot are going to be adopted by industry? Is that a, you know, long-term trajectory, or do you think that's shorter term? Can you maybe speak a little bit about your thoughts about technology advancement integration on the body itself?
So we rolled out this the VX controls concept at the Utility Truck Expo. And I have to say the response from some of the larger fleet providers was tremendous. I don't want to talk about individual fleet providers, but some of the larger both last mile delivery customers, as well as the utility companies, gave us an overwhelmingly positive response about moving forward quickly with integration of these technologies into their vehicles. In fact, some customers have approached us about retrofits to their existing fleets, taking VX controls and retrofitting it into their existing fleets. And some of them had even talked about, well, we started down the path of developing our own system because there wasn't a system out there. And it's really starting, we're getting a lot of pressure and positive feedback from our customers that they really want to move quickly to implement this. Now, getting when the rubber meets the road, we'll see, but at least at the moment, we're getting a ton of just positive feedback on both the integrated displays, the safety systems, and the exportable power. It's all been extremely positive so far.
Yeah, I mean, I'm not, I don't drive a commercial vehicle in a fleet. I've had the fortune of seeing commercial vehicles in a utility application, and I was amazed, and I've seen it from multiple utilities vehicles over my career, and I was amazed at all the different systems that exist within the vehicle, and especially as technology starts to come to bear to help drivers. But the flip side of that is, and you talked a little bit about it, and maybe I'll pull on that thread a little bit more, is about distraction. Because and particularly in the, retrofit environment, as, more vendors bring one particular component of a technology into the chassis to meet a particular driver need. I've seen some commercial fleet vehicles that are a little bit scary in terms of all the different things that are happening inside the chassis, and driver distraction, I think, has got to be going up without an integrated approach. Could you maybe speak a little bit more about that and what you're hearing from fleets?
So I mean, when we've first started the discussions with some of our customers regarding this, the main concern was the number of displays that the driver had to look at. He's got a routing display, he's got a surround view camera display, he's got a controls display. When he focuses down from his, looking forward on route, if you got to, okay, I'm looking for the third display to the right, which is not in the view, forward-facing view, it's a huge distraction. So that was one of the key things that we got from customers early on, is the information has to be provided to the driver when he needs it, that you can't have him, touching a touch display when he's going down the road, getting the information he needs, or looking across 3 or 4 displays to look for what he needs. It's got to be what he needs when he needs it. So if he turns on the right turn signal, turn on the side camera on that side, and turn on the vulnerable road user warnings on that side. So, that has been a really critically strong voice of the customer, because it's their drivers, it's their driver training, and it's their vehicles that get damaged, or people's injuries that they have to deal with when these things happen. So that's been a very strong voice to the customer.
Thank you. I'm going to jump into a couple of questions, and I'm not going to start at the top or the bottom. I'm going to maybe continue on that thread of driver distraction, because I think it ties into driver retention, and you touched on it several times about the demographics and making these vehicles drivable by a broader swath of the workforce. So one of the tendencies is, how can EAVX address the need for fleets to attract and retain drivers?
So I'm 5'9", Mark. I'm not a big guy, and I have driven a few Class 5 trucks, and it's a difficult vehicle to drive. The sight lines are not good. So if you were considerably smaller than I am, and if you've got a 36-inch floor height, it's big steps getting in and out of that. So We've worked very closely with our chassis providers to get a low floor height on a number of applications so that we can reduce the fatigues, especially for smaller drivers, to broaden the demographics of the drivers we can get. They reduce the repetitive stress injuries to them to make it easier for them to drive the vehicles and significantly improve the sight lines. I should have put a graphic in, but with the design I showed, it provides the sight lines for a 5th percentile driver are better than today's vehicle for a 95th driver.
Wow.
So really improving the sight lines on these vehicles so that smaller stature drivers can drive these vehicles comfortably, and then providing the safety systems on top of it that give the driver additional confidence that they're safe when they're going down the road. And everybody gets distracted. Even if you provide a very good interior cabin, still drivers will get distracted. So providing the warnings if they're going to fade out of the lane without using the turn signal, or if there's a risk of them back-ending the vehicle in front of them, those are the things that you have to provide for the driver going forward, because we need to broaden the number of drivers that can drive these vehicles.
Yeah, and I guess that last point you made, at the end of the day, it doesn't displace training, and it
Nope.
doesn't displace behavior reinforcement for drivers, but it's there to help kind of reinforce
Yep.
the training and their driving behavior. There's several other questions, but I want to ask you. We've talked about the driver and we've talked about the cab. Can you share a little bit of the thinking of EAVX and what's happening in the future on the back of the vehicle relative to last mile delivery? Or you want to share any of your thoughts on kind of where you see the future going relative to ergonomics and some of the technologies that can help drivers, for example, in the package delivery space, in terms of how technology might help driver efficiency and ergonomics in the back of the truck?
So the ergonomics, it's primarily focused on opening automation of systems so that the driver doesn't have to manually open or close things, that the vehicle knows what the driver is going to do next and automates it. And so the driver is not waiting for a door to open. The door opens as the driver unbelts the seatbelt and starts to turn around. So automating things that improve the efficiency, not just reducing the repetitive stress injuries. And then we've got a large focus looking at how we find a package in the back of a last mile delivery vehicle. I'm not ready to start talking about some of the technologies we're looking at, but suffice it to say, we're looking both at very, very advanced technologies to aid the driver in finding the package in the back of the vehicle, to pretty simple technologies to aid the driver in finding the package. And that's been my first meeting with one of my major customers when I joined EAVX. He looked at me straight and looked at the chassis supplier straight, and he says, "Which one of you guys' job is it to go find the package in the back of the vehicle?" And I raised my hand and said, that's my job. And the chassis providers kind of gave a sigh of relief. And the customer said, "I'm going to hold you to that." So I owe him an update in the very near future regarding that. But we are literally looking very, way down the road of how to do those things and really aid the driver to pretty simple technologies that we can implement pretty quickly right now to aid the driver in finding a package in the back and getting it to the front door.
Well, that's a great teaser, Greg. Maybe that'll be a conversation for a webinar in the future as you guys mature your technology and start to make announcements about those things. Looking at some of the questions here, one of the participants is asking, does EAVX see much opportunity or demand for battery swapping in medium duty transportation market? Do you see greater opportunity for enabling battery swapping in the specialty upfitter segment?
So we see a lot of potential for battery swapping in the upfitter segment. We don't deal in the chassis, so we're not responsible for the chassis design. We work with chassis partners on that, but we do see a strong space for battery swapping for a number of the workspace or work truck space environments. You know, exportable power to a job site, do you have to leave the vehicle there? Or do you just offload a battery system that has bidirectional power and charging capability, so you can run your equipment on the site or you can run the job site? You know, we see a large market there for exportable power, and even down to our tag and Master Rack brands of having power that's available that you can swap in and out, or leave at a job site, or move into a building at a job site and leave the vehicle outside. That is another area where we see a strong need for our customers. So,
Yeah,
so not only just swapping out, but being able to remove it to use it.
yeah, it's almost like a tender, right? The old field tender that would come and service the vehicles on site.
Yep.
Very interesting. Got another question here. How does EAVX connect the various technologies throughout the vehicle? What advantages are there to be gained?
So the advantage is you can, so obviously we're going to be using our CAN network. So we'll listen on the vehicle CAN. So we'll be G 1939 compliant. We'll listen on the vehicle CAN. We're not going to talk. We're going to try not to ever talk on the vehicle CAN because we don't want to upset the vehicle OEMs. But we'll have our own CAN network that we work with our technology provider. So being able to connect all the systems so that you can, you know, deliver what the driver needs when the driver needs it. So like I said, if you're turning left, turning on the left side camera so you can see it. Being able to, through a single display, monitor what doors are open on the vehicle or what cabinets are unlocked or open on the vehicle, making sure you're not driving down the road with a compressor running on the vehicle in the back of it. So being able to talk to the battery systems for exportable power, the tools in the back of the vehicle, the safety systems in the vehicle, all through one system and controlled through one system, we see as a critical thing going forward.
Great, and that actually I think ties to one of the questions we have here about, you know, is EAVX vehicle designs limited to just EV vehicles?
So that was initially when we started to work into it, at least especially for the walk-in vans, we were focused on designing for EV vehicles, but we've since broadened it, and we're going through what are the obvious compromises you have to make to package an internal combustion engine in the same vehicle. It may change the front end a little bit because, you know, we don't want to give up the ergonomics and sight lines for an EV that an EV vehicle has for an internal combustion vehicle. So it can likely change some of the sight lines and those types of things. But we do see the benefit of providing the aerodynamics and ergonomics that we're designing into the next generation vehicle for ICE vehicles also.
Yeah, and I think, you know, the whether it's security or driver awareness related technologies on the side of the vehicle for backing, I think those things, right, obviously translate beyond just an EV chassis.
Yeah, and like I said, we have a number of customers that are looking at the VX controls and would like to retrofit that to existing ICE vehicles they have in their fleets today, because they see the value in the automation and the driver warning systems.
We got a question. The in-cabin thermal demand issue sounds very significant. What are some conceptual ideas to solve that versus just adding a larger volume of additional batteries? which have negative implications for cost and weight. How do light duty EVs approach this issue? Are work vehicles substantially different?
So the issue with the work vehicles is the volume of the driver compartment. It's huge. It's not well insulated. So getting that compartment warm enough is just not. It's really not financially viable for an electric vehicle. So, I won't throw any of my customers or competitors under the bus, but there's plenty of information out there on commercial EV vehicles and range anxiety when they get in the cold environment. And that's driven by two things: keeping the batteries warm and trying to keep the driver warm. So it's a pretty well understood issue with the vehicles out in the field today. But targeted heating specifically of the driver and specifically of the windshield is critical in this. So, heated seats, heating steering wheels, and other directed heating to keep the driver warm, and then concentrating the heat directly on the windshield. You can't use the standard heat vent today. So we're working on technologies to get the heat right to the windshield, and the side windows, so that you don't waste a lot of heat heating the cabin, because you just don't have the energy on the vehicle to do that. It's not financially viable to do that.
Yeah, I mean, we've talked about heating and obviously you guys in being in Ann Arbor, that's a big issue there. Maybe could you speak about the cooling side and maybe some of the southern parts of the country that have to deal with that issue?
And we're looking at a number of things. If you push me today, I'd have to say it's going to be a pretty. It's going to be a refrigerant base. It's got to be a refrigerant based system. Just from an efficiency standpoint. I mean, we've looked at thermopiles and different technologies like that. The efficiency is just not very high, and the temperature gradient you get on them, we haven't found a system other than a compressor-based refrigerant system, and then using that system to focus specifically at cooling the driver rather than trying to cool the cabin is the important thing. So, it's not going to be a big automotive system that you see today with a, giant compressor. It's going to be a very small, very targeted cooling system that's focused specifically at keeping the driver cool when he's sitting in the seat. Because you can't cool the cabin even with a 3-to-1 efficiency for a refrigerant-based system. You still just can't expend that energy to do it.
Okay, great. Thanks for that. If there's more questions, please submit them in the Q&A. I have another one here about how might urban type delivery trucks contrast with rural trucks in terms of design, technology, and equipment.
So that could be a whole webinar on its own. It gets into, in some cities, you're just not going to be able to bring 1,000 cubic foot truck into inner city areas. So we are looking at different methods for last mile delivery, using micro mobility solutions. There's no choice. The cities aren't going to allow it. Traffic congestion when you're parking a 1,000 cube truck too deep in a major downtown city street, you just can't continue doing that. So we're looking at micro mobility solutions going forward to help with that last mile delivery. Smaller vehicles, obviously, even if you are, and then some type of tender system where smaller vehicle goes to a micro hub or a tender, and you deliver packages to that. Same thing with the micro mobility. It goes back to a tender hub, gets resupplied, and then goes to the next location. But we have to look at those types of things because our customers need them, and regulations in some of the cities are going to drive out a large percentage of the vehicles we build today.
Yeah, I mean, I don't want to, I don't want you to talk about specific customers, but maybe could you talk a little bit about I'll say the breadth of types of vehicles that EAVX and your family of companies is looking to provide solutions for, in terms of, smaller vehicles up through, medium class vehicles, and specifically maybe from the context of, this last mile delivery as it relates to inner cities and congestion issues they're grappling with. Maybe just tell us a little bit about the breadth of the types of chassis manufacturers that you guys are engaged with.
We've got a lot of well-announced partnerships with the number of chassis providers, being one of them. So vehicles that have four-wheel steer, that we could do much better in this urban environment where you have need very tight turning circles and those type of things. It won't drag over the curb as you go around a tight corner. The back end will track out and track around, follow the front of the vehicle around the corner. Those things are going to be important. As I talked about earlier, the micro-mobility, that's going to be critical, especially when you start looking at areas like Los Angeles and New York. Mm-hmm. It's becoming very expensive to deliver packages there because of what they charge for bringing a large vehicle downtown. So some type of hub and spoke micro-mobility solution is going to be important for some of those going forward. And we do see a push to move to today, a large percentage of our market is 1,000 cube walk-in van. We're seeing a downward pressure more in the 700, 800 to 500 cubic foot walk-in van. And we need to talk with our customers to address, is a 500 foot or 500 cubic foot walk-in van, is it just a shorter wheelbase with the same cross section? Is it a longer wheelbase, so a fifth percentile driver can reach packages easier? What is, when you downsize to a 500 cube or a 700 cube, what is the optimal from their perspective as to what the vehicle should look like?
Mm-hmm. You've got your work cut out for you for sure.
Yeah.
Another question here: how far along is the EAVX with designs and deployment, and what about the service side?
So one of the big things about JB Poindexter is the breadth of the company. I didn't include a slide in it, but there's over 180 different service and upfit centers that are either owned by JB Poindexter or licensed through JB Poindexter. So we have a very large network of service centers out there throughout the U.S. That we can, and we are primarily a U.S., Canada, Mexico company. We don't sell anything in Europe today. So we have a larger, from a commercial vehicle standpoint, we've got a very large service network out there. So there's going to need to be a lot of training, a lot of design consciousness for safety for EV vehicles and EV products going forward. I mean, the exportable power or ePTO applications, designing the systems so you really mitigate the chance that anybody working on the system or using the system gets hurt, and then good training for those service centers when these systems do come back to them.
Mm-hmm, mm-hmm. Yeah, I mean, I've seen that map, and it's quite extensive, and
yes,
there's pockets of concentration.
Yep.
Obviously, like on the East Coast, for example, and in different pockets where there's population as we move westward. So that's a great network that you'll be able to leverage. We've got about 10 minutes left. Just a couple more questions, Greg. This one's a little more specific. How does the missing tool cabinet systems / sensors work? And how often do these cabinets end up being left open by workers? What have you heard from customers?
The big thing we've heard is the lost tool. So it's a simple RFID system for the lost tools. That was a huge feedback that we got from the utility truck show from customers we had not anticipated. Even walk-in van customers were like, "Oh man, we lose a lot of carts." Bakery customers, the number of trays they lose every day is staggering. So, keeping track of those things, making sure they go back in the truck when they're done at a specific location is very important to them, because you lose a high value tool, it can be thousands of dollars that they leave behind. So that's a critical one. We've gotten a lot of feedback on rear lift systems, that is a critical issue, where people are using them in box trucks. They lower it down or leave it folded down and get distracted, end up back in the compartment and start to drive away with the lift system deployed on the vehicle. So even providing a warning, or having it, you can't put it in drive without pushing a second button that says, "Yeah, I know it says it's down, but I want to drive away anyways," if a sensor fails or something like that. It is feedback that we've gotten, especially with the rear lift systems, because those are expensive systems. So if you damage it by driving off with it deployed, you can severely damage that system, or damage the vehicle, or damage vehicles around it.
Right. And I mean, I am a commuter, so I consistently, at least once a week, see a vocational work truck going down the freeway with a cabinet ajar or open.
Yep.
So I mean, it's not, a random thing. It's pretty regular. Any comments on that?
And the safety aspects of that, because things are going to come out of those cabinets, and work trucks, some of those things are not small. So you're now putting a projectile into the road, and it does happen on quite a frequent basis, because I mean, they're all human. They get trained how to do their job, but they're all human. They make mistakes. And maybe they thought they got the cabinet all the way closed, and maybe they didn't get it, latched properly. Making sure, having redundant systems that aid the driver and help less trained drivers do their jobs well is really important. And it is something that happens on a frequent basis.
Yeah, so safety and liability for those fleets, right?
I had an experience where I came to the traffic light right down the road from my house, and there was a 10-pound hammer on the back bumper of a truck.
Oh, wow.
So I walked up and politely knocked on his window and said, "Hey, you may want to go get that."
Yeah, before it becomes someone's nightmare.
Yes.
Maybe one last question here. And so this is my view on this is, part of this might be relevant to the electric chassis, but obviously, as you think about electric systems on the body itself, maybe you could speak about it in both terms. What demands are you seeing on charge rate for work trucks or work vehicles related to charging? They ask about DC fast charging in the 50 to 100 kilowatt hour range, 200, 350, or extreme charging ranges. Any comments on that, and where you see things headed?
So we see requirements going from 10 kilowatt an hour charging rates. A lot of our fleets are centrally fueled overnight. So they would bring the vehicle in, plug it in, wait for the lowest rate, utility rate, and then turn them on and let them charge overnight. An 8 or 10 hour at a 10 to 15 kilowatt hour charge or kilowatt charging rate is plenty for them. Some of our work truck suppliers that have trucks that are, 24/7 during storms and those types of things. We see requirements for 100 to 150 kilowatt hour charging. But we're also getting a driver from them of how do they charge them while they're on the road? So what is the 2-gallon gas can of the future when you have an EV vehicle? So that's another solution we're being tasked to provide for primarily our utility customers is where is the 2-gallon jerry can of electrons for when these things need to go from a work site to home when they've been deployed all day due to a storm.
Yeah, and it's interesting in some of our own conversations, with you around maybe there's a role for hydrogen to play on that aspect of it. But, well, Greg, I greatly appreciate you taking the time to come share, the insights from EAVX. Clearly, you guys are thought leaders in the space, and we're super happy to have you in the CMC ecosystem and in working with some of our chassis startups. And I appreciate you coming in and sharing your thinking today.
Thank you very much. Thanks. Appreciate it, Mark.
All right. Have a good day.
You too.
Thank you. Once you exit the webinar, please take a moment to complete the short survey that will pop up on your screen. A follow-up email will be sent to you with a link to the recording. Thank you. This concludes today's CMC webinar.